So welcome to my final project presentation. So the dataset that's given to me is about the networking dataset. So the idea of this analysis is to analyze whether the incoming packets from the network, is it having any attacks, is it in the right order, and to do analysis and in real time, explore, find the attacks and respond to it. So I'll be building a pipeline to stream data in real time. To the downstream data team so that they can say implement the data analysis and machine learning algorithms to detect any anomalies in attack records and do the further blockages on it. So the approach that I have taken is I'll be loading the raw data in the S3, and first I've planned this in 3 phases. So the first phase I will classify in doing this part, and the second phase as this, and the third phase as this. So in the first phase, I would be getting the data from the S3 buckets, doing the transformations using glue jobs, using AWS EMR, and just verifying the outputs through AWS Athena. And then I'll move on with the phase 2. So let us start with the phase 1. I'll give you an abstract expectation of what I'm going to do here, and after that I'll show you a practical example in the AWS console. So first I'll be loading the data into the S3 location, then I'll be using Glue crawler to extract the data into the Glue databases. Then I would be developing doing the first transformation. So I would be filtering out data using TCP and UDP, and for this I'm planning to do a Glue job using PySpark in the backend. And then what this job does is it transforms the data and loads it back to the table, and from the table it takes back through the next S3 bucket. So from the next S3 bucket, I'm going to do my transformation to where the S3 bucket is the source, and I'll be using an EMR job to classify label 1 records into another new S3 bucket. And from there, what I'll be doing is I'll verify the working of it using Athena if whatever transformations and cleaning we have done is working fine or not. So this is the phase 1 of the video, and these covers in the phase 2 and phase 3, which I'll be explaining it later. So let me start. So this is the basic idea on whatever services I've used as a part of the implementation for the project. So I'm using AWS S3. I've just listed down what all S3 buckets, CIM policies, and the services that I've utilized: Glue, EMR, Kinesis, Flink, Firehouse, data streams, and Snowflake and Airflow is what I'm using for my project. So this is a phase 1 implementation, as I just said. And so basically, as I said, I'll be first loading the raw data from the Kaggle into my S3 bucket. And from there, I would be creating a glue crawler to crawl the data into the tables. So you can just see here, I've created a crawler and I've run it, and the data is reflecting into my tables. Now I would be validating this in my using Athena. So I'm just trying to query it out, and I can see the results coming in. Then I'm doing my first transformation or data cleaning here. So for this, I'm going to plan of implementing an AWS Glue job using PySpark in the backend. So what this does is that I'm initiating. So I've developed a job script. So the script says, say I'm initiating all the parameters here. I'm initiating the session here, and after here, the logic is basically this. So whenever the data in the proto column is in TCP and UDP, pass it on into a new data frame, and I'm passing the data frame into the table. And from the table, what I'm saying is I need it to go to this S3 path. So it goes and sits here, which would be my second source from where I would be taking the data further for my further process of So here, if you see, we can just query it out and see. Initially we had 1000 records and now 951 records. So 49 records have been filtered out. Now comes my transformation 2, for which I'll be using an EMR job to filter out the attack records. So basically, whatever records that's coming in, I'm going to find out whichever records are the actual potential attack records, and I'm ignoring all the records which are in good order. So for this, what I'm doing is I'm creating my EMR cluster. So basically, I'm creating a basic cluster with one master node and two slave nodes, and I am enabling SSH connection so that I can connect it from my local. So I'm planning to do using VS Code, so it would be easy for me to work upon it. So I'm establishing an SSH connection into the EC2 instance, and from there I'm connecting to EMR, and from there I'm creating a VI editor and I'm pasting my Python code. So what my Python code says is it collects the input path, basically the last transform path from the glue job, and it says I'm defining the output path, which is the third S3 bucket that I'm planning to dump my data into. And now what happens is I'm saying if label is equal to 1, classify it as attack records. So in order to find out if my job has run properly or not, I'm printing out statements saying how much is it before, how much is the count before and how much is the count after the filtration. So doing this, what it does is the data gets stored in the new S3 bucket. So this is the logs you can see. So initially when we see here, we can see that these are the connection parameters basically, and it says successfully uploaded into CSV format into the S3 location, and you can see the CSV file being loaded into the third S3 bucket, P50 attack records. And to validate this, what I'm doing is I'm kind of creating another crawler to crawl data from this into another glue table, and from there when I'm trying to print it, you can see I can see around say yeah, I can see the filtered out records here. So this is the part one of my implementation, and then I would be carrying out with the phase two later. Now I would in the next video I would show you an implementation in the AWS console on what I've done so far. Now let us start with my phase one, the implementation, what I've done in the AWS console. So basically, initially, I've defined all the S3 buckets that I need for the project. So I've defined my raw data, the filtered records, the attack records, and the final table, bucket where my process data would move in. So after defining all the tables, I'm checking for all the roles. So initially, instead of say each and every time giving a new role, I created roles, which two roles basically, which gives me most of my accesses for most of the AWS services. So these are the common roles: P50 service role 1, service role 2. All the other roles are part of the project when it is needed. Say when we created a Kinesis stream, it automatically creates a role and I would be giving permissions on top of it. So all these roles are related to the project, but these two are the major roles in the phase one. So once this is done, what I'll be doing is I'll go and check through my glue, because these are the initial crawlers that's going to take in the data from the S3 and move it on to the glue tables. So in my S3, I'll go into the raw data bucket, and you can see the table being loaded. So the CSV file. So this is the CSV file that I'm loading, and what I'm trying to do is I'm creating a crawler and I'm saying load crawl the data from the raw table and put it into an glue table. So once I run it, once I create it, I'll run it, and it says the last run was succeeded. So if you can just go here and see, you can see that one table has been changed. So while creating the crawler itself, I've created the database. So this is the database, and this is important because this is the database that I'm going to keep using throughout the project of my final project, and everything goes into this database. So if I go into this database now, you can see uh, all the tables are created as a part of the project. So our raw data comes into this uh, table basically. So if you want to verify the output of this, you can just go ahead and do uh, say a basic select statement on Athena, which would give all the respective rows. So if I'm just running this, you can see that it's loading. Yeah, we can see how many total records are there in my data set. So this is in incremental fashion, so it's there. So, but I've taken a sample of 1,000 records. So that is what would be my data set with which I would be working further. So let me close this. And after closing, so this is the step one that I'm doing my phase one. Now, then what I'm going to do is I'm going to start doing my transformations. So I would be taking data from this table and passing it on to my further jobs and processes, which would return the output to the further tables. Now, say I'm creating a glue job. So if I go here, you can see that I've created a glue job. So this is a PySpark code which uses PySpark in the backend, and this is the script that I've developed. Uh, I would show this in VS Code, which would have a better understanding of it. So I've just named it as transformation one for easy understanding. So as you see, I'm creating a Spark contest, then I'm creating a Spark session, and then I'm creating the initial data frames. And here is my logic, and I'm saying whenever the data comes in TCP and UDP, because these are more prone to the attack records, pass it on to a new data frame, and then create a new table with the table name like this, and then um, create a new table where the transform record goes and sits, and also put those records into this S3 path. So if you go here and see, if I go into my glue tables, the output of that would come and sit here in this table proto filter, because using the proto column in TCP and UDP web transform, I can show that in the same in my S3 as well. So I'm saying the output that I've mentioned is this proto filtered thing. So if I come here, proto filtered, yeah, this is the output of the of the PySpark code. Now this is my transformation one. For the transformation two, I plan to implement it using AWS EMR. So as we have the requirement here, so what we have to do now is based on label one. So label one is classified as attack records. So based on this, we are going to do a filter and then move it into the third S3 bucket, which is defined as attack records. So yeah, let's go on. So this is the code for it, the EMR code. So here I'm passing in an input path, and I'm saying this is the output path. And then um, in order to differentiate between before how many records was there and after the filtration of the attack records, how many records are there, I have put a print statement. So this gives me out the initial records, say 950 records are there, and after transformation 850 records are there. So I can just easily find out if my script ran successfully or not. And also I've printed out a success message if it moves and sits in the S3 folder. So yeah, so what I'm saying here is the logic basically is when label is 1, move it on into the filter data frame, and from the filter data frame, write it into the S3 output part. So that's the logic behind this. So for this, I'm using uh, basic EMR cluster of one master node and two slave nodes. And that's enough basically for my project. Based on your data requirements, you can scale it up and down on whatever is needed. So I would show the output of this after it goes and sits here, and then we can take it from there. So I'm going into my S3. I'm going into the bucket that is this. And here, if we go and see, we can go into this. Yeah, so this is the respective output. So inside this, we have the records, which has only the attack records basically. Now, in order to verify this, we can go ahead and query this. So I have something, the same table that's created from there comes and sits here. And here, if you go to Athena and verify it, view data, and run a select query, we can see how it has performed. Yes, so let me run this. Yeah, so now you can see 914 records here. So initially in the raw data set, we had 1,000 records. Then after the proto filtered, we had 951 records. And now we have 914 records. So we are filtering out the records that are not needed for our analysis. And now, so that is majorly we are done with this phase one of our project. I would go back to the data architecture and explain what we can expect in the second phase. So we are done with this part. So basically we loaded data into our landing zone, and from there we created a crawler to load data into Glue, and from Glue we developed Glue job using PySpark to do the proto filter and put it into my second S3 bucket. And from my second S3 bucket, we did a second transformation using AWS EMR. And using EMR, we put the attack records into the analytics, basically the attack records bucket. Now from here, we queried it and verified the output in Athena. Now what we are going to do in phase two is we are going to stream the data, which is only the attack records. And using streaming, we are going to pass in, because in real time data comes in millions of rows every second. So we need to scale up and be ready for that. As we know, packets just come in and go just like that in so quick pace. So in my second phase, I would explain how Kinesis data streams work, and then we would take on with the further analysis using Airflow and Snowflake. Welcome to the part 2 of the video, and now let us see about what we have done in the previous step and what you're going to do now. So far, we have done the basic data transformations and stored the required attack records on the S3 bucket. Now from here, we will be moving into more complex concepts. We will be streaming the data via Amazon Kinesis data stream, and we will be doing a real-time data processing through Apache Flink, followed by fetching the data through Firehose and storing them on S3. And then we would be analyzing the data according to the pipeline. So now we are going to build this part of the pipeline in this part 2. And in the part 3, we will be focusing on the final part, that is orchestrating an Apache Airflow DAG and loading the data into Snowflake and analyzing the data from Snowflake SQL. So now let's start with the part of the video. Now let's basically understand what is Kinesis data streams. So Kinesis data streams is an AWS managed real-time data streaming platform wherein we are ingesting data from any real-time sources. So we have an IoT device, any robotic components, any web services wherein data comes in regularly and we have to manage it. So we would be creating streams that work in form of shards, and it is then streamed into a landing layer. And here comes Apache Flink. So Apache Flink is an on-the-fly open source real-time data processing framework. So it is used for data processing of any stream. It can also do batch processing. Then we have to understand what is Firehose. So we would be getting data in form of streams, and the streams has to be landed into a landing zone, be it an S3 bucket, Redshift, or any databases. And Kinesis Firehose does that job for us. So it consumes data from the stream and then it stores into the required data lakes. So this is the idea of the data pipeline, and let's start from the step one. So first we will have to, I would carry it on this way. I will just explain the theoretical part firstly, and then I would show it in the AWS platform. So first we are creating data streams, which is the Kinesis data stream. Here we are creating two streams, one from where we are receiving the record from the S3 bucket, and two to take the record onto the S3 buckets again. And then in order to run Flink, we are creating a studio notebook in managed Apache Flink under AWS Kinesis, and inside here we would be using SQL logics, basically Flink SQL, to do some data processing. And here is the code for that. I would so basically I'll explain a rough flow of the code. So in this code, if we see, we are creating while creating the stream, the notebook itself, we would define the databases and the glue properties of it. So we are creating a table and we are defining the scheme of the table basically on what the data source is about, and then we can partition it and give the stream name. So basically it is saying whichever data comes through the stream has to utilize this schema and store the data. So based on the incoming data, it would be converted into a table format. And now what we're doing is we are creating a results table. So in this results table, whatever is coming through this, we would be doing the transformations and storing it into this table. And the results from this table would then be further taken into the required S3 data bucket. So again, we're defining the schema for this. And after creating, we are saying insert into the results table on what is there in the initial table based on the conditions if the service is unknown or if the service is equal to DNS. So based on these two conditions, we are going to ingest the data into the results table. Now after this, now basically how we are doing this is once we create the studio notebook, it will open in a Zeppelin notebook in AWS Flink. So here we would be repeating the same code and we would be running. So basically if we see, we can run and view the logs, but that is not a dynamic way. So we would be creating an application which does which with which we would put a trigger. If any data stream comes in, automatically this notebook would be triggered and it would be placed in the respective data stores. So you can see that here it says build SQL Flink and then deploy. So basically we are running this by building it and then we are deploying into AWS. So by deploying, what happens is that whenever a stream comes in, it when and it is triggered, automatically the application runs as defined in this configuring the Flink notebook. We would have defined that. And then now we are going to kind of um, deploy the application. So once it is deployed, you can see the message successfully created, the notebook and the application is deployed. You can see into Apache Flink applications. And after this, what we are going to do is we are going to give the necessary IAM roles before we carry on with the execution of the application. Now we are running the application. You can see starting the application. So once this is done, what we are going to do is that we are going to see if the application is running properly. For that, we can just move into Apache Flink and then we can see if it is in the running state. Now after this, as I said, if the application has to be triggered, first the stream must come in. So we are writing a Python script which is basically saying take data from the S3 data source and then put it into a stream. Now when the stream is called, this Flink notebook activates. So you can see I'm using both3 library from Visual Studio using the AWS SDK feature. So I'm defining my access key, secret keys. You can just give your unique keys, whatever you have, the regions, and then configure the S3 source along with it. Everything, Kinesis client along with the credentials. This is the SDK library. You can just go with a quick tutorial if you want to know more about it. And here I'm defining the stream name. So this is the input stream. That's from where I am ingesting data from the S3 source. So I'm saying convert this into a JSON format. So from the CSV file, the data comes into a JSON format, and then it says load this into the stream you with a partition key on I've defined as services. So on the services as and the service as partition, it gets streamed into this. And here I'm saying like in like 0.25 means in 1 second I'm saying pass in 4 messages through the stream. And here I'm just giving a rough, I'm iterating through the stream. So it gives 3 copies of the CSV file and stream. So here I'm triggering the stream and you can see the output. Now here, if you see the message as HTTP status code as 200, it means the stream is successful. So that's the HTTPS success code for it. And now once a stream is going in, I said the application would get triggered. So once the application is triggered, what is the goal of the application is that it should pass on the transform data through the SQL statement. As we said, if the data is in if the service is unknown or if it is DNS, it should pass it. So once that is transformed, it is passing into the result stream, which is this. So now if you see, you can see some data is coming in, incoming data, put records, some incoming data here is shown. So like that, you can confirm if it is working fine. And the same way, if you move into the application, there also you can see data coming in and how the CPU is being utilized for that. Now, step 3 of this process is that we are going to create a Firehose delivery stream. Now, what this does is this consumes data from this result stream, basically the output stream, and this places the data that's coming through the stream, basically the transform data of the real-time data, into an S3 bucket. So now this is the final phase of this part 2 of this analysis. So we have created a delivery stream here, and after creating delivery stream, um, the delivery stream, we define it as a source and destination. The source is going to be the Kinesis stream, and the destination is going to be the S3 bucket. So while creating here, you can see the confirmation that the stream is created here. So this is the delivery stream, and here if we see, again we can see records coming into the delivery stream. So this is like from the uh, result stream into the delivery stream, and from here where it has to go to the S3 bucket. And if I go to the S3 bucket, I can see here folders created. Now if I move into this folders, I can see the resulted files that I need, which I would be further carrying on for my analysis in the part 3. Now I'll just give a quick illustration of what we saw on the presentation in the Amazon's console. Now that I've shown you the theory part of what we have done, I'll show you practically on the AWS console on what and how I worked. So now first let me move to AWS Kinesis, and inside Kinesis, as we first discussed, on step 1 we will have to create the AWS data streams. So let us go into data streams, and if you see here, there are 2 streams that I've created. One is for the input stream. So what this does is this picks in data from, as in it ingests data from the S3 bucket into Kinesis data stream. Now this Kinesis data stream we would be using to consume data through Flink and process it further. Now this is the result data stream. Now once we process the data, it has to be moved again outside. So this pipe takes in data of the transform data into another data stream, and from here we will use Kinesis Firehose to consume the data and move it back into the new S3 bucket. So this is the part 1. So first I've created 2 Kinesis data streams. The creation of data streams is simple. You can just like go in and see the configurations. It is just we have to mention on demand mode or what we need here. It's not something that's complicated. If you go to monitoring, you can see as I've already triggered the script, you can see that data coming in huge volumes. You can see all the metrics that's available here in the CloudWatch monitoring section. You can see all the data that's coming in, what is the average ratio of getting records, how much incoming data is coming in, and everything. Um, the same thing you can see in the results stream as well. So if you go to the results stream, so what is after the data is transformed, you still see all the data that's moving in and out. Now I'll just show you a quick way of how you create a stream, but since I've already created, it's not a big deal. You can just mention the stream name, you can mention what mode, and you can just create stream. And once you club this with the respective services, it automatically runs on top of it. So the step 1 is done. Now afterwards, now we are getting we have created an input stream from where data comes in through an S3 bucket. Now we will have to transform this incoming stream, and how we are doing that is we are doing it through Apache Flink. Now in Flink, there are 2 features. One is Studio Notebooks and Flink applications. Studio Notebooks is used for defining the code. Once the code is defined and tested, what we'll do is we will deploy the code as applications, since that is a dynamic way of working around. We cannot go and each and every time trigger a script which runs in the backend. It should be automatically consumed, and that is where applications come into picture. So first let us start from what we did in part of Studio Notebooks. So this is the notebook. It is a Zeppelin notebook. And once we deploy this notebook, it gets created as a Flink application. Now I'll open this notebook for you, and this opens in Zeppelin, which is like a Jupyter notebook format. And once I open this, I can see the code that I've defined inside this. Now here what I'm saying is I'm while creating this Kinesis Flink itself, I would define what is the source, what is the destination, what is the database, all these basic configurations I would have done. So I've defined on what database these tables should be created. So you can just quickly see. I can show you. I can just go to, this is actually AWS Glue, and inside Glue I'm going into databases. So this is the database that we are using throughout the project. So I'm going into this database and I'm saying inside this database create the respective tables. So that's all that is doing. So here if you go, it's saying drop table fixes, and for name easy naming conventions I just put p50, which is my project, and my stream1. So it creates in the name of my stream1. So I'm defining the schema here on what is there in my CSV file, and then I'm saying whichever data that comes in through the stream, uh, make it up into the schema format and load it into this table. So that is what I'm defining here. Now this is a raw table we can consider. Now from this table I'm going to transform data, and for that I'm going to create another table, and for that I'm saying in easy naming conventions as results table. So once data comes in through that, I'm doing a basic transformation that says uh, say insert into the results table from the initial table based on service, if the service is unknown or if the service is equal to DNS. So now this one would pass in through this stream and it would store the data into this table. So that is all it's explained in this pipeline. So if I have to show you here, I'm getting the data from S3 bucket onto my Kinesis data stream through my stream1, and after that, I'm consuming the data from my stream1 into a Flink application and I'm transforming on the fly here. So after doing the transformation, it has to go into another zone. And for that, I'm passing into my second resultant stream, which is here. Now we are in this part of the process, and after here comes our third part. Now why I wanted to show you here is, as I said, we have to do it dynamically. So here I would build an application. So since I've already built it, it's not showing out for me. I have to build it. Once I build it, it is like a stage that is ready for deployment, and then I'll go ahead with deployment. So once I click here deploy to AWS console, what will happen is it will create a Flink application, which is this. So this is something that it automatically created based on my deployment. So this is nothing but Flink application, and you can just see whether the Flink application is running or what is its status. If you see here, I'm going to my Flink application, it opens a super dashboard, and here you can see about the job details, if it is running, what is the status, start time, duration of how much minutes it has run, and everything. And then here you can go ahead and you have to run the application. So once you run the application, it is always active. So whenever the first stream gets activated, it triggers this application, and this application is responsible for passing data into your resultant stream. So what does your resultant now at this point you have data into your resultant stream. Okay, so in the resultant stream, you have to use my step 3. In the step 3, you are consuming data from the resultant stream into a Kinesis Firehose. So here if we go again into AWS Kinesis, we have seen what we are doing in data streams, what we are doing in Flink, and now we are going to Firehose. So Firehose, as we have studied already, it just consumes data from the stream and then it stores into any landing layer. It can be an S3 bucket, it can be a Redshift database, or anywhere. So if I go here, you can see the configuration of it. The configuration says the source is this data stream, which is our resultant data stream, and we are saying put this data into this Amazon S3 bucket. So it places the record into this Amazon S3 bucket. Again here, once we create here, when the application passes data into the Kinesis data stream, since we have defined this as the source here, it automatically triggers this delivery stream, which then moves the data, or like pipes the data into the respective data store. Again, um, you can see the logs here. If I go here and go to monitoring, you can just see that data which is coming out of the stream, a result stream, and how it is moving into the respective data stores. You can see that data is coming here, and based on its volume, you can see all the metrics that's being monitored here. Now, how do you confirm if the data is moved on to the resultant S3 bucket? And this is how you do. You can move into the buckets. So I'll go into my Amazon S3 buckets, and if you see here, I have all the buckets. So this is the bucket that I've given as destination. So I go here. So these are not folders that I created. It is created by the delivery stream itself. So you go into this, you can go into this again, you can go here, and here you can see the resultant files. So these are the files that are being stored by the delivery streams. So this is the overall part of the phase 2. Now under this, I'm not doing anything much. I'll just trigger my initial stream, which does all the other jobs for me and completes this part 2 for me. Now from here, what are we doing? We have the resultant uh, details into our S3 bucket. From here, we would be passing data into our Snowflake by creating DAX through Airflow, and we would be analyzing it further. So that's it about this video, and let's catch up in the part 3 of the project. I just missed a simple part in the previous video, so just complete it here. So I said we are triggering the initial data stream. So this is what is done. So I would be doing it through my local system through Visual Studio Code through AWS SDK. You can do it anywhere. You can use a Cloud9 instance for this. You can use any other IDE for this. I'm using VS Code. So here using SDK, I'm defining my access keys here, and I'm saying I'm connecting to S3, I'm connecting to Kinesis client, I'm defining my stream here. So this is my input stream, and inside this stream, I would be passing in the data. So here I would be defining my bucket details here, and the file from where I'm going to stream the data. So this is the major part of it, and after this through SDK, I'm just saying once the data comes in into the stream, I'm converting into a JSON format, and after that what I'm going to see is going to say put it into the stream based on partitioning. So I'm doing a partition with the service key. So here based on this, it partitions and loads data into the stream, and that's how the initial stream is loaded. So once the stream 1 is triggered, which is the input stream, automatically your application gets triggered, and once your application gets triggered, data is processed and it moves on to the resultant stream. And once it moves on to the resultant stream, your Kinesis Firehose gets activated, and your Firehose delivery stream takes data from the resultant stream and stores it into the S3 bucket, which is further carried on for the analysis. Now I'll just quickly run this thing for you so that you can easily analyze it further. So I'm just running the script. And you can just see how the data is moved on, how it is, this is how it is streamed. So I'm just defining saying run through the data 3 times in a loop, and so if I have 1000 records, it will repeat itself 3 times, and 3000 records get streamed into the, and here the secret of understanding how if it is successfully streamed, you have this HTTPS status code which says 200. So 200 is the success code for the data stream. So that's what I wanted to cover here. Once this is done, your entire streaming is done, and let's catch up into the part 3 of the video for further analysis. So welcome to the phase 3 of my presentation, and here we go. So starting with, this is the idea behind phase 3. So now we have the data that we got through the streaming into the S3 bucket. So here, from here, what are we going to do is we are going to move data into Snowflake, which is a data warehouse, and we are going to achieve it using Apache Airflow, so that we can orchestrate the overall process rather than relying each and every time to run it manually. And then on top of Snowflake, we are going to do a lot of analysis. Maybe we can use this as a warehouse. We can pass it to downstream teams like data analytics teams, where they can build beautiful dashboards, and to data science teams who can build ML algorithms to find the attack records and say implement a block on the respective attack records. So there are a lot of applications that goes from here. So our duty is to pass it to Snowflake and do some basic analysis on top of it. So setting up Snowflake. So what is Snowflake usually? Snowflake is a data warehouse that runs on cloud, which spins on top of AWS services like cloud services like AWS, Azure, and GCP. So you can just create an account on whichever cloud provider you need, and you can take it from there. Snowflake is of late getting a lot of traction in the market, sheerly due to its compute and storage. Because it is cloud hosted, the compute time is really quick and you only pay for what you use. So there are a lot of advantages in Snowflake. I would recommend to go and read behind what Snowflake is there to offer. So now basically in Snowflake, I've created my account. Then I would create what all are the definitions that needed for me in this project. So I would create basically firstly with the database schema and tables, and from there I would say how to link AWS with Snowflake. Basically how we can kind of transfer data into Snowflake from AWS services. So yeah, so these are the basic things. So first I've created a database in the name of P50 final DB, a schema and a table. This is the table definitions. I'll attach the table definitions, the code, in the code folder, and you can just check it from there. Now, how do you set up a connection from AWS to Snowflake? It looks to be easy, but it's a bit complicated because you can hard code your credentials like AWS key and stuff and easily do it. But that is not the right way of doing it. You have to have a say a very strong way, or I would say a very secure way of doing it. So for that, what we are doing is we are following a set of process, creating some IAM policies, and from where we are creating an external a unique number, and from AWS we're generating a unique number, which is what ultimately would communicate. So first we are creating an IAM role. um, this is the JSON that I'm using for creating IAM role. So basically this JSON says so why I'm using this is, I said security is most important here, as interacting between two different providers is always risky. So what I'm doing is I'm creating a managed policy. So managed policy is something that, say, I am only having control over a particular service. Say here, I am only giving access to Snowflake to access a particular S3 bucket. It can't access anything else. So I'm creating a role which is particular to this bucket. So only this bucket it can read and write records. So that's the concept on what we are going to do now. So for that, first I'm creating a policy, and for creating a policy, this is my JSON. So in that I'm saying you can access recurse through files only inside this folder, and the same thing goes here. And here it says the policy is created, and we would be granting that policy into this role. So into this role, once I create, I would get a unique ARN number for this. I'm just making a note of it. Now what I'm doing now in Snowflake, how do we generate a unique ARN number? So for that, this is how you do it. So I would go to Snowflake, and I would just quickly show on what I've done so far. So if we go here, you can basically see this. So we are creating a storage integration. So what a storage integration does is um, it creates a unique ID. It creates a unique I have my code file here which gives more context on what I'm talking about. Yeah. So this gives you two factors. One is that when you run this, you can find it out. So you can just see, you get something like, you get a unique ARN number and a unique external ID. This was what I was referring to. So this external ID is the most important thing for communication with the AWS services. So what I'll do is I will add this external ID and this ARN number into my AWS role. I can show you where I'm adding it here. See, if we go here, and if I'm going to my roles, um, uh, just give me a second, this is loading. Yeah, so this is the role that I'm using for this P50 Snowflake access role. And here, when I'm going inside, if I go to trusted relationships, so here external ID, I will be replacing this field with what is there, and ARN number here on what is there with my Snowflake. So these two are ultimately responsible for communication with the managed AWS bucket. What are we achieving by doing this? We are not hard coding any credentials, so this gives you more security in through the process. And yeah, so first, this is the command for creating the storage integration. and this is the command for like viewing what are the properties and what are the configuration items of the Snowflake integration, means storage integration. So the name of the storage integration is P50 S3 integration. Now what I'm doing is I'm creating a file format. So basically I have a CSV file in my S3 bucket, so I'm creating a file format. If you go here, you can see all those. So this is my final schema. uh, so here if you go, you can see my file format which I've defined here. Now on top of file format, Snowflake is a bit different to traditional databases. You can't load data directly, you'll have to have a staging layer because it is a data warehouse, and from the staging layer you kind of read data continuously. So I'm creating a stage here. So what we saw there, we saw that we can talk to this AWS bucket. So inside this AWS bucket, I'm trying to access the CSV file which holds all our attack records on all the three layers of transformation we have done, which is the proto filtered, which is the service filtered, and finding out the attack records based on the label that is equal to 1. And now I'm saying use this integration, so this refers that I can have access to this and use this file type, so recognizing it to be CSV file. If you have other file formats like avro, parquet, or JSON, you can just define the file format here and then feed it here. So after doing this, I'm going to list out my data stage and see what it comes. So yeah, here you can confirm that the data stage is properly loaded. You can see the size, you can see that one row is returning and everything. So now after this is the query that I'm going to use in order to load data into my final table. So this is my final table. So I will use this, load my data, and now we will verify if the data is loaded successfully or not. Yeah. So the data is successfully loaded. We have 547 rows after all the transformations are done. And here on top of this, we are going to do all our analysis. Now, each and every time we can't keep manually running the copy, say the loading part of the SQL, say data comes in regularly, we can't keep each and every time triggering this. So we need to set up an automation process. Basically in this place in data engineering, we orchestrate the flow of data, and for that the best tool in the market, which is the market leader, is AWS Airflow. So Airflow was initially developed by Google, which was then open source. So we would use the Airflow for the flow orchestration, using the AWS managed Airflow service, and I will be doing it in the next phase of the video, and that would be our final part of the phase 3. And you can do any analysis on top of this, say how many attack records came in, from which IP address a lot of attacks came in, which protocol had more attacks. All this you can do a lot of analysis basically and pass in this data, or say this table data from this table will be consumed from the downstream teams. So let's meet in the next video where we discuss more about Airflow. Hey, so welcome to the final part of the presentation. So in the last part, we saw how data is configured through Snowflake and it is moved on through analysis, but it was done manually. Now we will try to orchestrate the data flow through Airflow and see how it works. So there are two ways of creating an Airflow tag. So one, we can spin off Docker containers. Now we are using AWS, so there is an Amazon managed Apache Airflow through which we can configure also. Now here I'll be doing it with the managed Apache Airflow through AWS service. I'll first explain the code quickly and then we'll go ahead with the other parts of the thing. So initially, if you see, I have created a tag with two S3 buckets. So basically one saying as processing folder and the second being the processed folder. So my DAG would first trigger the Snowflake query. So first I would say load the data into the schema, and once it is loaded, it will move on to the processed folder. So also this keeps happening regularly. So in an incremental fashion, we can orchestrate the data flow and there is no manual intervention needed in this part. So this is the logic behind the flow. So I'll be running, I'll paste this into my S3 bucket here. I can show you it quickly. So this is my S3 bucket. And if we go here, I've created a bucket, and inside the bucket I've pasted my DAX and a requirements file. So this is the bucket where my DAX are placed. we go into Airflow, here we have the DAGs, and here I have my requirements folder. Into my DAGs, I have my Python code, which we just saw what is configured here. And after that, I also have a requirements folder. So this is a basic text file. This just has what is needed as a part of this project to implement, basically the dependencies that the Airflow DAG needs. So I'm installing AWS CLI here and an Apache Airflow provider Snowflake. So these are the ones that's needed for the execution of our DAG. Now, in order to execute the DAG, in order to create the Apache managed Airflow through AWS, there are a certain set of configurations that we'll have to take in care. We have to create a VPC which should allow the networking parameters so that AWS Apache can communicate with Snowflake. So we are creating that. So that takes in the network parameters. Then I'm creating my monitoring factors, like setting all the scheduler logs, workflow logs, web server logs, and everything. Followed my I'm also creating a role which should have access through my S3 bucket. Once you spin off this cluster, it takes around 15 to 30 minutes. So if there is a delay in it, there's nothing to panic. So I've already ran my DAG. So you can just see here, and followed by this, I can show the data that has come into my S3 bucket. So if you run here, you can see the data that's here. Even in the manually when we ran, we still saw 547 column rows, and here also we are seeing 547 rows. Now once this comes on top of this, we can do our analysis. Say in the requirements we had to find how many attack categories are there and the count based on the attack categories. So I've just set up a query for that, and we can see for the various attack categories how many attacks has happened. So this is a query for that, and you can do a lot of more analysis. Say I'm planning to see from which IP address more attacks have happened. So if we go into this, we can just see that there are 4 IP addresses that's majorly contributing for the attacks, and these sort of analysis can be done. Now here we have warehoused the data, and this data can be consumed by the data analysis teams, business teams, machine learning teams, and they can process it further and implement the algorithms so that they can detect the attacks, whatever that comes in. So that is about the project. I would once finally show the architecture, and we can wrap up here. So initially in the phase 1, we got in the data into our S3 bucket. We did some basic transformations through AWS Glue, EMR, and we developed a glue job for it and stored it into a proto-filtered layer. And from there, we developed an EMR function which uses PySpark in the backend, and then again stored it in the analytics layer. So this is about the phase 1, followed by phase 2, where we stream the data that we have in our analytics layer through AWS Kinesis data stream, Firehose, and Flink, and we store it in S3. And from here, and we moved on to our phase 3, where we moved data into Snowflake through Apache Airflow, and we did analysis on top of it. So that's basically the idea of the project, and hoping to meet you guys soon on another project. Thank you.